Shall we start? Let's make this happen. So first of all, this session is about how you can implement microservices architectures with .NET Core and Docker, specifically about microservices. Okay. Something important that I want to highlight is this session is 45 minutes. I was trying hard to get 1 hour and 15 minutes, but I was told by the organization we couldn't make it. We couldn't change it. So I'm going to need to go quite fast in order to cover all the content. Let's introduce myself first. My name is Cesar de la Torre. I work for the .NET team and Visual Studio team in Redmond. Scott Hunter's team, Hanselman team. And yeah, let's start. OK, something running. So something I want to highlight is anything I'm going to be talking about in the session. We created a reference application with demos about that and also a reference book. It's a 300-page book that I wrote about microservices architecture, and you can download the PDF for free in that URL. And about the sample application, we released this sample application a few months ago. It's been consistently in number 2, number 3 about C# repos, more trendy in GitHub across all C# repos. And you can see, I mean, a lot of forks. We have more than 1,000 forks of the reference application. And recently, we've been migrating from .NET Core 1.1 to .NET Core 2.0. So right now, it's .NET Core 2.0. OK? So when talking about microservices, and there are many patterns on one hand and also many new technologies. So there are different things. You can use those technologies for microservices or not. But then when architecting and developing microservices, there are many patterns, most of them related or even coming from domain-driven design. I'm going to talk about some of them. Others, you can read about them in the book, right? And the talk is about microservices and implementation with containers. But I really want to highlight this, that microservices is not equal containers or vice versa. How many in the audience here have experience with Docker? Can you raise your hand? OK, so maybe 1/3. OK, so I'm going to do a quick introduction about Docker before getting into microservices for those that don't know containers or Docker. But basically, you can use Docker containers with other server applications. Could be a monolithic web application, could be a monolithic service, and vice versa. You can also create a microservice architecture with just processes and no containers. Okay, so it's a different thing, but they are really a great fit. So probably like modern new microservice applications, most of them are going to be using Docker containers now and in the future. Okay. So quick intro about Docker containers. Basically, it's a technology that runs on Linux and Windows. And kind of the bottom line is how many times do you even yourself, you had something working in your machine, and then, hey, it's not working in production. What's going on? And you say, well, it was working in my machine. I don't know what's going on. And usually it's because you have all the dependencies in your machine. And then in the production servers, maybe there's one dependency missing, and that's why it's failing, right? So this is precisely what Docker solves on the containers. Because a container comes with all the dependencies that your process needs. So that's why it's going to improve a lot your deployments. That's the key thing about containers. It's self-sufficient. And when talking about containers, do not think about virtual machines, although it's kind of somehow virtualization because you have own IP and isolation and so on. But from a development point of view, think more about a process. A process equals container. A container has a single entry point for a process. So think about more like a process with all the dependencies that it has, right? Then about Docker and .NET, we have two kind of images. One image for full .NET framework, which is logically just for Windows Server Core. So it's a larger image. You can run legacy applications in there as well with IIS and so on. And then the .NET Core images because .NET Core is cross-platform. You can run any .NET Core container on Linux or Windows containers or Linux containers, okay? What else? Then about Docker, you can also use Docker to modernize or lift and shift your existing .NET applications, kind of legacy applications, something that is already running on full .NET framework. When you're lifting and shifting to the cloud, well, of course, you can just move your monolithic application to infrastructure. But the point would be more if you try to, you migrate it and use Windows containers with that legacy application. So this is not the subject of this session. I'm going to deliver another session at 2 about modernizing existing .NET applications, monolithic applications with Windows containers. The subject of this session is this one. It's about cloud-native applications, microservices, .NET Core, and orchestrators, okay? So this is this session. And let's go into microservices architecture, right? So if you compare a traditional application like free-tier, monolithic, and so on, the difference on the left is that you have a single application, maybe multiple modules or subsystems within that application, but you have a single deployment. And then if you want to scale out, you need to deploy that whole application in different nodes, different VMs, right? But then it's kind of coarse-grained. And so if you want to scale out, you have to scale out the whole thing. And even worse, if you change something in one of those squares, one of the modules, that might impact the rest of the application because it is a single deployment, right? With microservices, it's different. You split or decompose your applications in multiple services, and then you deploy those services with multiple instances across multiple machines, usually kind of organized by an orchestrator. And then that is going to allow you 2 things. One, you will have a much better density per hardware. So that's good for total cost of ownership. But more importantly, you'll be able to scale out independently one part of the application or the other. And even further, you could have different development teams working on one microservice and another microservice, and they could be working in parallel without impacting their deployment. So you can deploy one microservices and not deploying the rest if you have like a good architecture, okay? But the most important point about microservices, I think, is more about the data. Because if you are just using services, that would be more like service orientation, and we've been doing that for years, right? A microservice is more similar to bounded context in domain-driven design. So the microservice has to own its own data. So on the left, you have like a traditional application. You could have different services, but then you have like a monolithic database or a few, but they are shared across the services. So that is not a microservice approach. If you really want to have a microservice approach, each microservice has to own its data. It could be a database in SQL or NoSQL in MongoDB, Cosmos DB, or even stateful services in Service Fabric. So that's one of the most important things. So this is the reference application that we created, eShop on containers. I mean, the business domain doesn't matter. We chose e-commerce because it's a very well-known domain for anyone. And basically, you have a Xamarin client application, a traditional, well, not traditional, MVC web application, .NET Core as well, a single-page application using TypeScript and Angular 4, and then different microservices, identity microservice using ASP.NET Identity and Identity Server. So the same token, security token, can be used by the web applications or Xamarin. And then different microservices like the catalog or basket, CRUD. The ordering microservice is more complex, is more domain-driven design internally as well, with a domain DDD, domain aggregates, and so on. That's because it has a more business logic, the ordering. And then the basket microservice is using a Redis cache in a container. Marketing is using MongoDB in a container, and then if you move it to the cloud, it would be using Cosmos DB because the protocol is the same. And then for asynchronous communication, so updating or propagating information from one microservice to the other, when you update, data, we're using an event bus. An event bus is an abstraction. Underneath, we are using RabbitMQ in a container, or if you move it to Azure, you could be using Service Bus or any other Service Bus like nService Bus. I will talk about that later. So let's do a quick demo of that. So this is one. OK, so when you install Docker for Windows, you have these settings where you can share drives. This is important so you can debug with Visual Studio your containers, or you can assign more memory to the Linux VM. So in this case, by default, I'm using .NET containers, .NET Core, and running on on Linux. So you can see in there, Docker for Windows installs this virtual machine, Linux, which is your Docker host. You could also run Docker containers on Windows, but then it would be running natively on Windows. Okay? But in this case, I'm running on Linux because .NET Core is cross-platform. So if I do a Docker PS, I already deployed the application because I don't have time to, it would take like two minutes or so. All the different containers that I mentioned. So my services, web applications, and then there's a MongoDB container, a SQL container, SQL Server container, a Redis container, and RabbitMQ container, all running in the same machine. So this is the application. You can, add products to the basket. Let's add one more. So now we have 4 products here. You can see here the basket. We will get into it later. We have the single-page application, which is kind of similar, but it is using Angular. So, like for instance, if I filter here, you see that it's not reloading the page. So it's everything under the covers from JavaScript. And let's go to the code quickly. Here you have all the multiple web API services. Each of them is running as a Docker container, like the basket API, catalog API, locations, and so on, ordering. And then the web applications, WebMVC, WebSpa, and the web status is like a watchdog application, so we know what's the health of each microservice. I will show it later. And something important in Docker is that each container is going to have a Docker file. Let's say catalog application, Docker file. You see here the Docker file. So I'm using ASP.NET Core 2 for this container, and this is the entry point of this container to my web API. And the other beautiful thing in Docker is Docker Compose. So with Docker Compose, you can kind of deploy a multi-container application at the same time, and even set dependencies. So this is my Docker Compose for the whole solution, and you see my services, basket API, the image I'm using, and then it is depending on the basket data, which is Redis container, identity API service, and RabbitMQ container. And the same for all the rest of the microservices or containers in this case, right? So all my microservices. And at the end, you see that we are also spinning up RabbitMQ container, Redis container, and Mongo container, and NoSQL, right? We are using many different technologies because that's kind of the philosophy of microservices. You could be using different data, different even languages for each container. That's why they are decoupled, okay? And well, that's almost all for now. We will get into more details in a minute. So, yeah. So key patterns for microservices. And this is where we get into details and about what do you need in order to create a microservice-based application. It's not just using Docker, because it could be a monolithic application. So microservices patterns, kind of the most important would be these. For the first one, I'm not going to have time to talk about it, but basically is that you have many microservices, and then how are you going to consume them from the client applications? Could be direct communication from the Xamarin application or from the web application, communicating directly to the microservices. That is direct communication. Or you can also create an API gateway. An API gateway is something you put in between, so you can do aggregation of data across multiple microservices, or you can put just the security at that level, and then the microservices are kind of hidden in the Docker host, things like that, right? And also you can use products for API gateways, like Azure API management can be considered, even it's a lot more, but can be considered an API gateway. Next thing are health checks. I'm going to talk about that. Resilient cloud applications. When you move an application to the cloud, you have to embrace transient failures and how you can recover from that. And then asynchronous communication with public subscription communication and how you can scale out with orchestrators. So the first topic would be health checks. So you need to know about the state of your microservices. Are they healthy or not? And it's not just about the web API process or container. It's also about their dependencies. Like in this case, that microservice is dependent on a SQL database. If that database fails, I want to say, hey, this microservice is not healthy because its data is not healthy. So I want to say it's unhealthy. And then if I'm asking about that from even a watchdog application like we have here, and I will show you, or even from the orchestrator, you won't be redirecting HTTP requests to that microservice. And so this is the case where you have the same thing, but then the orchestrator itself is kind of asking to the microservices if they are healthy or not. And if they are not, the orchestrator won't be redirecting HTTP requests, okay? So, well, and you'll see now in the demo about health checks, we created a library that you can add to your microservices for that. So it's very simple, and then use these health checks from this library. This library is the source code. It's in the reference application, but also it's going to be a building block in the next version of ASP.NET. So probably ASP.NET 2.1 is going to be part of it, along with other features that we want to add about microservices in ASP.NET. The next thing would be, OK, if you move things to the cloud, you have to embrace that in the cloud, you're going to have failures, and many transient failures. Like, let's say you have a database in Azure SQL database. That database eventually might move from one node to another, one machine to another, and for a matter of maybe 2 seconds or something like that, maybe you don't have connectivity. If at that moment your microservice was trying to access that data, you will get an error. And maybe 2 seconds later, it's going to be OK. So you need to have that into account, or maybe just because of transient failures in the network. Like you're requesting something, and just for a microsecond or half second, you couldn't access the other microservice. So for that, you need to implement resilient communication in your microservice application, because everything is going to be distributed. It's not a monolithic application. So you're going to have a lot of communications between the microservices. So techniques for that is you can use retries with exponential backoff, and then circuit breakers, so you protect from dying yourself. I will explain that. So let's explain this. Retries with exponential backoff. Let's say I have a client application requesting to my API gateway, and then I'm requesting to that microservice one. And then that microservice, for a moment, is not responding for whatever reason. So then maybe I just want to try a few times, because maybe it's going to respond eventually in 2 seconds, just in case, right? So I do retry 1, retry 2, retry 3, and then it is up. So it was just a transient failure. It responds, success, and now it was resilient. You are not propagating an error because it was transient. But let's say that it was not transient, it was really dead, then you eventually have to respond with an error. So that's why you have the circuit breakers. So circuit breakers, it's the same thing. You ask to that microservice, do retry 1, retry 2, retry 3, but then you put the limit, and then, OK, so in retry 4, if this microservice is not responding, I open the circuit, and I raise an exception. But I can send like a business message about hey, this part of the application is not ready for whatever reason. Okay, so this is exponential backoffs, retries with exponential backoffs, and circuit breakers. we recommend, and that's what we're using, Poly, which is a library for retries with exponential backoffs and circuit breakers, and you have many policies for that. If you're using Java, it's more like Netflix history could be comparable. So I'm going to do a demo about this, about health checks, like 2 demos in one, about health checks and also retries with exponential backoff. And I had to compress this in one demo. So first of all, about the health checks. So here you see the building blocks, and we have a health checks for SQL or for URLs, for HTTP, and so on. So this is what we are using. Let's say in the catalog microservice, I go to the program, and the only thing I need to add to use this library is in the web host pipeline. I add this, use health checks, and /hc, that's going to be kind of the URL to ask about, are you healthy or not? And then also after that, you can also put dependencies between one microservice or the client application and other microservices. So for instance, I do that. If it is about SQL, for instance, in the catalog microservice, you see that in the health check, let me search for it. In this document. OK. You see in this case, add health checks, and I'm adding the SQL health check. So if the database, the catalog DB is not available, I will say, hey, I'm not really healthy as a service because my dependency is not there, right? And the other thing you can do is you can go to like a client application, the MVC application, and then you can add multiple health checks. Like the web application is depending on the catalog microservice, the ordering, basket, identity, and marketing. So if any of them is not healthy, then the web application would be healthy. You can play with it, maybe put some of them, others not, maybe depending on what is critical or not for the client application, okay? So just to show it quickly, you can see here. So this is the Swagger for one of the microservices. It's in port 5103, and this is the basket microservice. So right now I can access to it. I see Swagger, all the methods, and so on. And when I call this URL, you see the localhost /hc. This is the health check entry point, and is responding, I'm healthy, okay? So that's how this application, the Watchdog application, I reference it, you see I have all the microservices healthy, and the web applications below, WebMVC, WebSpa, healthy as well, okay? So now I'm going to show you about the transient communication. So basically, one thing about transient communications is about SQL. So using SQL and Entity Framework is really simple to have that transient communication with SQL. When you are creating the connection, right? The connection string, instead of just having the connection string, you add as a SQL option that you want to enable retries, okay, on failure. So that's going to be done under the covers for you for SQL. So that's pretty simple. The other case is for HTTP. So for HTTP, what we created, and you can reuse here, is we created a building block for resilience HTTP. So basically, we have an interface, iHTTP client, and 2 implementations that you can use using dependency injection. So one implementation is using the regular HTTP client. It will be using regular HTTP requests. But the other one, the resilient HTTP client, is going to be using the policies of Poly. So you can say, hey, I want to do like 5 retries each time, just in case I'm getting an error, and then do a circuit breaker. Like in this case, you see the policy here. I have 6 retries, and then the circuit breaker is going to be starting with 5 retries. Okay? So let me demo that, how it works. So let's see. So right now, you see that we have the application working. We can go to the basket, right? Let's simulate that the basket microservice dies. So for that, instead of killing the container and starting the container, which is going to take more time, we created a middleware which simulates that the microservice is failing. So you see this middleware calling /failing. Right now it's disabled, so that's why it's working. But if I set this middleware, I enable that, now any HTTP request to that microservice is going to respond HTTP 500. So let's say if I try to connect to HC, so now it's not healthy. If I try to go to Swagger, it doesn't work, right? And even further, if I go to our health watchdog application, you see that the basket is unhealthy because we are asking to that endpoint. But even further, you can see that the web applications that were depending on that microservice, they are unhealthy as well for that, okay? So now it's failing. Let's going to try to use that microservice and see how we're doing those retries. So I try to go to the basket up above. So, and then you see that it's taking long. Under the covers, what it's doing is it's going to take a while because it's trying, and then every time it tries, it's going to take more time. But you see here in Visual Studio the exceptions and how Poly is kind of catching those exceptions and retrying again. And eventually, after 6 retries, it will open the circuit, and then it will get the exception and show it, right? So it's going to take just a few seconds because we are trying and trying quite a few times. Again, you can see here in the Watchdog application how it is not healthy. So just a few more seconds, and we will get the business error because of the open circuit, okay? Something I want to say about this while we get that business error. The thing about retries, you see that now the circuit breaker pops up and say, hey, the service is not operative, and that's why we show the exception. So circuit breakers are very important because if you are not kind of stopping those retries, then think about having multiple failures in your microservices. Then you have a lot of retries from many microservices and the web applications. That's going to be scaling like crazy, and you could be causing yourself a denial service. So maybe everything would go down because of so many retries. So that's why you can do retries, so you have resilient communication, but then you need ways to stop that with circuit breakers, and so you don't have denial of service in your application. So if I go now and I disable the middleware, so you see now it is working. It is working also from Swagger, and the application, the health check is working. And from the application, if I go to the application, and now I can go to the basket, okay? So that's the demo about resiliency. Let's move on. Okay, and this is related to what I was saying about if you have like a lot of microservices, a lot of communications between HTTP communications between microservices, that could be a problem, because then if you have an issue in one of the microservices, maybe it dies, or maybe it's just going slow, that's going to impact to the other microservices if you have like long chains of calls, HTTP calls, because something is going slow here or broken, that's going to impact to the whole application. So that's why there are anti-patterns here, and because if you are just calling many microservices like crazy, eventually in fact, you are kind of creating like a monolithic application, but based on HTTP, and that's going to be even worse than than a monolithic application. So how to minimize those exponential failures in microservices? One thing is circuit breakers, but the other thing, and to me is even more important, is from the architecture point of view, is avoid long HTTP calls across your microservices. So this is the kind of the anti-pattern. So you have the client application, and then that client application is calling one microservice, which is calling another one, and another one, and another one, and then it's coming back. So it's like a single chain of HTTP calls across many microservices. Think about that, and then multiply by thousands of communications across microservices. And then one of the microservices is going slow or dies, then your application is gonna be bad. So the recommendation is, okay, you can have HTTP requests to your microservices, but try to minimize that across microservices, only between the client applications, API gateways, and first level of microservices. So if something happens in one microservice, just propagate that asynchronously to the other microservice, like I'm going to do in the demo. Price change in the catalog, I'm going to propagate that price to the basket asynchronously with a message, like using publish subscription with a messaging broker or service bus, okay? So you see that I'm propagating that data across microservices, and when the client is asking to the basket, it's going to be a short HTTP request. So that's the best way, so one microservice performance, or if it dies or whatever, is not going to impact the rest of the application. You can do that with messaging, with AMPQ, or like Service Bus, or RabbitMQ, or N-Service Bus, or Mass Transit, any messaging system. Or you could also do that, depending on the case, using also HTTP, but polling, right? So if something happens, I update something in that microservice, the other microservice is polling, and hey, do you have something new? Yeah, then I get it, but they are just asking, so you're kind of simulating asynchronous communication with this, and right, polling one with the other, but when the client application is asking for something, it's going to be a short communication, right? And then something happens, and then the other one is polling. So the last one I prefer asynchronous communication because it's more elegant, and also it's like pushing with publish subscription when something happens. The other one is going to generate a lot of communication all the time. But sometimes it's better. It could be more scalable because it's HTTP, and then you can cache HTTP calls. And for some particular scenario, you could do also polling. Okay. So in the reference application, we are using an event bus, and an event bus is just an abstraction, like an interface and client API. And underneath, we have multiple implementations. We are using RabbitMQ, a single container when we deploy in the development environment. Or if you moved your solution to the cloud, then you just, with dependency injection, you use the other implementation using Service Bus, Azure Service Bus, or even other Service Bus in the market, like Mass Transit or N-Service Bus. And in fact, N-Service Bus, I'm going to say that later, they also created this reference application using N-Service Bus this week. So I'm going to talk about that. So let's do a demo about this. So, yeah, so let's say the demo is I'm going to change something in the catalog microservice. So here you see the event bus building block. So at the end of the day, we have an abstraction, iEvent bus, which is something like subscribe to this message, or unsubscribe, or publish this message to the event bus. Okay, so these are integration events. And then this is an interface, and we have multiple implementations. So you can then use the implementation we have. Let's zoom a little bit. So the abstractions, and then implementation for RabbitMQ or for Azure Service Bus. Okay, and then you'll see that the N-Service Bus folks, they also created another implementation for using N-Service Bus. And then when I go to the catalog microservice, you can see here in the controllers that when I do a change, like I update the product, then I'm publishing this to the event bus, published through event bus, okay? And then if I go to the basket microservice, which has to be aware about changes in prices, we have an event handler here called product price changed. So when I get this event, then I do something with that. Like I look for all the baskets that has that product, and if the price is different, then I'm going to tell that to the user, okay? So that's a way to communicate with asynchronous integration events between microservices, and that's the recommendation. So I'm going to do a demo running it pretty quickly. So you see here we have 4 items in the basket, okay? So what I'm going to do, because we don't have here in the web like a manager for the products, is using the here Swagger, so I can update the product in the catalog. So I can use directly Swagger here, query. You can see here that I'm getting quite a few products here. Let's get the first one. Okay, this data from Swagger in JSON. And you see that here we have the price. So now, using Swagger and updating this microservice directly, I'm going to update it on the put method, put that data, but I'm going to change the price. So instead of 8.7 that you can see here, 8.7 in this product, so I'm going to put a very expensive price, like 99. Update it. So now it happened under the cover is, OK, I updated the product in the catalog microservice. Yeah, if I reference here the application, you see that the product was updated. But the cool thing is that I submitted a message to the event bus. And because the basket was subscribed to that, it got it. And you can see that it's true because I'm here monitoring with RabbitMQ. And you see this was the message that I just sent. And the average message just 1, right? So when I go to the basket, now you see there's a message here. Note that the price changed. It was 8.7, and now it's 99. And it's been communicated asynchronously. OK? So let's move on. And yeah, I want to also announce this, like the particular software guys. They created that. They've been working on this for quite a few weeks. And this week, because we wanted to announce this for this event, they created a version of eShop on containers using nService Bus. Because what we're doing with RabbitMQ is like a proof of concept. It's great for understanding microservices, asynchronous communication. But if you want to put that in production, either you can put it on using Azure Service Bus, which is scalable, but also you can use other service buses in the market, like nService Bus, which is richer from an application point of view. So it's not just messaging. They also have sagas and many other application things for asynchronous communication. And then the final thing is scaling out microservices. So we've been talking about .NET Core, Docker, kind of the development environment. When you move to production, you want to move all the data into high scalable databases and high available, right? So instead of a MongoDB container, you move it to Cosmos DB database, highly scalable. If instead of a SQL container that we have in the machine, you move to SQL database, high available. Instead of RabbitMQ container, you use Service Bus. And then instead of running just those containers, one instance per container in Docker host, you move to an orchestrator, like Azure Service Bus or Kubernetes in ACS, in Azure Container Service. So, because what we want to do is we want to scale out. Instead of having a single instance, like you saw in Docker with Docker PS, we want to have many instances per container. So basically, you will have images, you have your microservices, web APIs, and you deploy that into the orchestrator, like many instances of your containers per type, right? And that could be Linux or Windows. So there are quite a few orchestrators. Personally, I would recommend either Service Fabric or Kubernetes in ACS. Service Fabric is more mature in Windows containers. Kubernetes is more mature in Linux. But both are kind of my preferred orchestrators. Docker Swarm is very easy, but probably is not so production ready. And DCOS is very much more complex and maybe more oriented for data than just simple containers. So that's kind of my personal recommendation. And then a quick demo about ACS and Service Fabric. So here, I have this same application deployed in an orchestrator cluster in Kubernetes in Azure and also in Service Fabric. So you see this is another cluster in Service Fabric in Azure. This is Service Fabric Explorer. So you see all the different microservices deployed in Service Fabric. And then you can have multiple instances here per microservice. Oh, sorry. Thanks a lot. So again, so here you see in Azure, deployed ACS, Kubernetes, and also Service Fabric in Azure. And this is Service Fabric Explorer. So you can see multiple, all the containers here deployed, and you can have multiple instances. And in Kubernetes, deployed in Azure, this is Kubernetes, the dashboard. And I want to do a quick demo here. Like, let's say we want to scale out the catalog microservice. Right now, it has just a single instance. We're going to scale out. And let's have, instead of one instance, we're going to have 4 instances. OK? And then you see here, it is scaling out. We will have multiple pods. So each pod is kind of comparable in most of the cases to instances. So you can see now 1, 2, 3, and 4 pods in the catalog. If I go to deployments, you can see now that it's been already deployed 4 of 4. If I kill one of the pods in here, like one of the instances, let's kill this one, because it dies for whatever reason, then the orchestrator that dies, but it is creating this one right away. So it is trying always to have 4 or to have 500, the number that you set. Okay? So you see that I killed that one. If I go again to the deployments and about the catalog, again we have 4 of 4, even when we kill one of that. And the same, it's comparable when using Service Fabric. And yeah. So we have 2 minutes. So again, you can download the ebook. It's like 300 pages explaining all these and many more things that I didn't have time to talk about. Most of all, these are kind of the things that I didn't have time to explain. Things like more internal domain-driven design patterns that you can use also in microservices. Like for the ordering microservice, we are using a simplified CQRS. We are using Dapper for queries and Entity Framework for transactions. We are using a real domain model with aggregates and value objects and domain entities in that microservice. And then also domain events. So domain events are within a single microservice, and integration events are across multiple microservices, right? And also security, many other things that you can read in that. Go to this page. On this page, you have not just information about microservices, but also about many other guidance that we are creating about .NET. So you see here is the area about microservices, the PDF. We have also this book online in docs, so you can also read it online. But also other areas like this is going to be what I'm going to be talking about today. So about modernizing existing .NET applications with Windows containers. And So go to that URL. It also has information about patterns for Xamarin and mobile applications or UWP. Okay. Key takeaways. So Docker is going to solve you deployment issues. You can use it for any server-side application. Very soon it's going to be ubiquitous. To me, it's going to be like TCP/IP or HTTP in the future. And then microservices is a different thing. It's more about the architecture for applications, complex applications that, like mission-critical applications that need to be scalable, multiple development teams. So it's not suitable for all applications. For many applications, maybe you just want to still have a monolithic web application. So this is when you're creating something large, multiple development teams, you want to scale out this area and not this area, because it's going to be harder to work with microservices because of the things that I was talking about, the communications, resiliency, and so on. But for many applications, it's great. You have great benefits. You can have different development teams working with each microservice, scale out, and so on. So it's a great approach, but it's an architectural approach. There are related sessions here. And with that, I think I made it in 45 minutes. Thanks a lot.